In this video, I will go over the homework that is after the lecture 0.5.3 called the properties of integrals, and I hope you watch this lecture as I discuss in it the few of the main properties of integrals. And let's start the homework. I don't expect this homework to be too lengthy because, well, there's only so much you can do with the properties of integrals. Let's start it. And to summarize the properties for definite and indefinite integrals, both of them inherited the linearity from the derivatives. That means if you integrate a linear combination of two functions, it will be equal to the linear combination of their integrals. And in this case, the integral is -5 of f of x plus 5x to the power of 5. And using the linearity, we can rewrite it like this. And the problem specifies that the antiderivative of f of x is 2x to the power of 5 over 3. And the antiderivative of x to the 5 we actually know. So this is the final answer. We got -10x to the power of 5 over 3 plus 5x to the power of 6 over 6 plus c. Very similar problem, so we're gonna try to be very efficient. So I'll just write the answer. The answer is 3 integral of f of x dx plus 4 integrals of x to the 5 dx. So the integral of f of x is given to be x squared over 4, and the integral of x to the 5 we know to be as x to the 6 over 6. And let's not forget plus c. Sometimes the hardest part of doing the homework is actually typing the answer carefully. Excellent. Another one of this, so we got -2 integral, which is given to be -2x cubed, plus 2 integral of x cubed, which we know to be x to the 4 over 4 plus c. So the answer here is 4x cubed plus x to the power of 4 over 2 plus c. I just love watching that progress bar growing, don't you? And another one of this, it's getting pretty boring. -4 times -x squared over 2 plus 3x to the 6 over 6 plus c. So 2x squared plus x to the 6 over 2 plus c. As soon as this message moves away, we'll continue. Linear combination, so in this case the answer is -7 integrals from 4 to 5 of f of x dx minus 3 integrals from 4 to 5 g of x dx. And if all of that is given, so integral from 4 to 5, they're trying to be sneaky. So here's an extra step. Integral from 4 to 5 of any function will be equal to integral from some value to 5 minus integral from that same value to 4. This is called the subdivision property of definite integrals. And in our case, we can just set a equals to 2, and then this integral will be equal to, just carefully not to mess up the numbers, -3 minus -2. And the final answer would be, let's just continue right here, 35 plus 3, 38. Excellent. Another one, very similar problem. We're going to have -4 integral from 1 to 3 f of x dx plus 4 integral from 1 to 3 g of x dx. And the integral from 1 to 3 would be equal to integral from 1 to 8 of f of x dx minus integral from 3 to 8 of f of x dx plus 4, and the same thing here, from 1 to 8 g of x dx minus integral from 3 to 8 of g of x dx. And the answer will be -4 times -6 minus 1 plus 4, -7 minus 4. 28 minus 44, -16. All right, the next problem is just using the linearity. Integral from 1 to 6 of 8 f of x dx is simply 8 times the integral from 1 to 6 f of x dx, but integral from 1 to 6 is integral from 1 to 9 minus integral from 6 to 9. And finally, the integral from 1 to 9 is just the opposite of integral from 9 to 1. And now we can see all the ingredients in place. So it's 8 times -9 minus -8. So it's 9 plus 8, 17. 8 times 17 is 136. All right, maybe a couple more problems and we'll be done. Another similar problem, so we'll be very efficient here. So the answer is 2 integrals from 1 to 5 f of x, but instead of 1 to 5 we're going to go from 1 to 6, which is the opposite of 6 to 1, minus the integral from 5 to 6. The answer is negative 22. And probably the last problem for this part. Oh, that was the last problem. If you have any questions about how to use properties of the definite and indefinite integrals, please feel free to reach out.